Okay, consider the function defined by the following set of ordered pairs. So this function takes -4 and turns it into -2. It turns -2 into -1. It turns -1 into 0. It turns 0 into 1. I'm trying to see what this function is, and I confess I am not getting it yet. It turns 2 into 4, and it turns 3 into 8. If you had to do an inverse, it would just be a function that went in the opposite direction. It would take -2, for instance, and turn it into -4. And it would take -1 and turn it back into -2. It would undo everything that first function did. It would take 0 and turn it back into -1. It would take 1 and turn it back into 0. It would take 4 and turn it back into 2. And from this last one, it would take 8 and change it back into a 3. So the original function, you give it 3, it turns it into 8. Give that to the inverse, and it'll turn it right back into a 3. You'll get your original value back every time. Now, they ask us to graph these two, this function and its inverse. So let's see what that gives us. Our original is -4 minus 2. 1, 2, 3, 4, 1, 2. Then we get -2 minus 1. We get -1, 0. We get 0, 1. We get 2, 4. And then we get 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's our original. And the inverse now is the ones I wrote in red. Can I get all that on the screen at once? Just barely. Maybe. Okay, so now we get -2, -4. We get -1, -2. 0, -1. 1, 0. 4, 2. 4 right and 2 up. And 8, 3 would be over here. They didn't tell us to connect these dots, but I'm going to because I think it'll make the next section easier. Our original function had a gentle curve kind of like that. And our new one is a mirror image of it, curving in the opposite direction. So blue is the original function. I'll call it f of x. And red is the inverse function, which I'll call f minus 1 of x. Not great notation, but it's widespread, so you have to get used to seeing it. And sorry, that's supposed to be a parenthesis. Draw a line which acts as a mirror between the original function and its inverse. In other words, an axis of symmetry between these. If you were to draw a mirror line for these, it would have to go something like this. If you have a line like that, and if you tilt your head so your left ear is on your left shoulder, you can kind of imagine that this blue line is some shape, and this red line is the reflection of that shape along this surface. Pretend this is a puddle or really smooth ice or something like that. You have the blue arch, and then this red is the reflection of that arch on the ground. This line is called the mirror line or the axis of reflection. And it kind of looks like it's y equals x. It turns out it's exactly y equals x, and one of the reasons for that, this is kind of a funny idea, but if you imagine that your original function had a point on it like, say, 5, 5, what point would be on the inverse function? You take these two values, you'd swap them around, and nothing happens. This line y equals x is the mirror line because it's the only place where these curves would have points in common. If you have a function and it crosses this line, the inverse will also cross that line at exactly the same places. It's the one place where the function and its inverse will agree, and their points will match. All along here are points like 0, 0, 1, 1, 2, 2, 3, 3, 10, 10. Those are all points where the original function and its inverse do the exact same thing. And so that's the line that both of these curves have in common.